Okay. The next point is geometry of a solution. Geometry of solution. Okay. Of semi-linear partial differential equation. Partial differential equation. Okay, now look at it. Consider the semi-linear partial differential equation. Semi-linear partial differential equation. Okay. कसं असतो semi-linear partial differential equation of the form p is the function of xy into small p plus q is the function of xy into small q and r is the function of x, y and z. Give it as an equation number 1. So this is the semi-linear partial differential equation. Okay, where small p is equal to dou z by dou x and small q is equal to dou z by zy, dou y, that is zy. Okay, now look at here. Now the left hand side of the equation 1, this side. Okay, the left hand of the equation 1, the LHS of equation number 1, okay, is called the directional derivative of the surface z of xy. It's called as the directional derivative of the surface z of xy. Okay, in the direction of the point p is the function of xy and q is the function of xy, this direction. Okay, we know that what is the directional derivative in differential geometry. Okay, what is the directional derivative? काय directional derivative म्हणजे काय?
So derivative in arbitrary direction.
In arbitrary direction. Okay, what is the partial derivative? Partial derivative काय सांगतो?
ते particular direction मध्ये असतो with respect to x axis.
X axis आणि y ला काय असेल? dou z by dou y. So in the arbitrary direction, it gives the directional derivative. Okay. So the left-handed side of the equation 1 is called the directional derivative of the surface z of xy in the direction of p of xy and q of xy at point x and y. Okay, now we know that the one parameter family, of curves in the xy plane, okay, it's characterized by the ordinary differential equation, okay, dy by dx, which is equal to q of xy divided by p of xy. Okay, so we know that the one parameter family of the curves in the xy plane, okay, it's characterized by the ordinary differential equation. Okay, dy by dx is equal to q of xy upon p of xy. Give it as an equation number 2. Okay, so this one parameter family of curves has property that z of xy, that surface, satisfies this ordinary differential equation. Okay, so this one parameter, it's one parameter family of surfaces of curves, family of curves has the property that the z of xy, okay, that surface satisfies the ordinary differential equation. Okay, what is the surface? Z is the function of z of xy. Okay, this surface satisfies this equation. Dy by dx is equal to q upon p. Okay, now differentiate with respect to x now. So dz by dx is equal to what we get then? Zx plus zy into dy by dx. Okay, so that implies dz by dx by dx is equal to zx plus zy. What is dy by dx? Q upon p. Okay, after simplification we get dz by dx is equal to p zx plus q zy upon p. Okay, but what is p zx plus q dy? Q zy? It's r. Okay, that implies dz by dx is equal to, what is the value of this one? Since capital P into small p plus capital Q into small q is equal to r. Okay, this is what? Zx and this is zy. So p zx plus q zy is equal to r. Okay, so r upon p. Okay, so the one parameter family of curves with parameter c lambda defined on this equation 3. Okay, give that equation number 3 are called the characteristic curves of equation 1. Okay, so this gives the characteristic curve of equation 1. Okay, so the one parameter family of curves with parameter defined with parameter c lambda defined the equation 3 are called the characteristic curve of equation 1. Okay, so this gives equation 3 gives what? The characteristic curve of equation 1. Okay, now let x naught and y naught be the point, be the any point in xy plane. Let x naught and y naught be any point in xy plane. Okay, then by existence and the uniqueness of this solution with initial value problem for the ordinary differential equation, we must exist there. The must exist the solution for ordinary differential equation. Okay, first year, first semester. Any ordinary differential equation by existence and uniqueness of the solution, every initial value problem has a solution. Okay, so let x naught and y naught be the any point in the xy plane. Then by existence and uniqueness, right? Uniqueness of solution of initial value problem. Initial value problem for ordinary differential equation. The equation 3 will define a unique characteristic curve. Okay, and say that curve is equal to x is the function of x naught, y naught, and t, where t is the parameter. Okay, and y is equal to y of x naught, y naught, and t. Okay, so this is the equation number 4. Say such that x of 0 is equal to x naught and y of 0 is equal to y naught. Okay, if z naught is the value of z of xy at point x naught and y naught in equation 4, it determines a unique solution. Unique solution, z is equal to, z is the function of x naught, y naught, and t. Then z is equal to is the function of xy. Okay, that surface is uniquely determined. It's uniquely determined along the curve, the characteristic curve passing through the point x naught, y naught, x naught and y naught. Okay, if we know z at point z of xy, z is the function of xy at x naught, y naught. Okay, if we know z is the function of xy, that is the surface at point x naught and y naught. Okay, after taking the example, you know very well. Okay, look at the example. First example. Solve the equation. Solve the equation zx plus zy is equal to z square with initial condition. With initial condition that, what is the initial condition? Z at point x and 0. Okay, y coordinate is 0. Okay, is equal to f of x, function of x. Okay, you have to find the solution of this partial differential equation with satisfying this initial condition z of x naught x0 is equal to f of x. Okay, look at the solution. Consider the given partial differential equation. Consider given partial differential equation. Okay, what is the partial differential equation? Zx plus zy is equal to z square. Give it as an equation number 1. Now we know that the characteristic curve of equation 1 is given by dy by dx. Okay, so we know that the characteristic curve of equation 1 is given by the ordinary differential equation. Okay, what is the ordinary differential equation? Dy by dx is equal to q of xy divided by p of xy. Okay, so here what is the value of p is 1. What is the value of q? Also 1. So dy by dx is 1 upon 1, which is equal to 1. Okay, so that implies dy by dx is equal to 1. So this implies dy is equal to dx. Okay, on integrating, we get y is equal to x plus c dash. Okay, implies x minus y is equal to c. Okay, so this is the characteristic curve. Give it as an equation number 2. Okay, so this is the characteristic curve of equation 1, that is the given partial differential equation 1. Okay, so this is the characteristic equation of given partial differential equation. Now, we again know that the one parameter family of characteristic curve is given by equation 2. Okay, have the property that z of xy must satisfy the ordinary differential equation. Okay, so we know that the one parameter family of characteristic curves given by equation 2, okay, have the property जे आपण थेरम मध्ये केलेले थेरी मध्ये तेच आपण याला करत जायचं आहे. ओके, सो प्रॉपर्टी that that surface z is the function of xy, okay, must satisfy the ordinary differential equation. Okay, which ordinary differential equation? dz by dx, okay, which is equal to what is the value of this one? Zx plus zy into dy by dx. Okay, but what is the dy by dx? Zy. Okay, so this is dz by dx is 1. Okay, so that dz by dx is equal to dz by zx plus zy. What is the value of zx plus zy? Z square. Okay, now putting the value of from equation 1. So dz by dx is equal to z square, since from equation number 1. Okay, so this implies dz upon z square is equal to dx. Okay, so now integrating we get what is the integration?
-1 upon z
-1
equal to
upon z.
x.
-1 upon z is equal to k plus x. Okay, where k is the integration constant. That implies z is equal to minus 1 upon a plus x, where k is the constant of integration. K is the constant of integration, or it may be the function of c. Okay, what is the value of c? X minus y is equal to c. Okay, this c is also constant now. So here we know we don't know that whether k is the constant or function of constant. Okay, function of c. Okay, so here where k is the constant of integration, or it may be a function of c. ओके, सी पण तुमचा कॉन्स्टंटच आहे. नुसता कॉन्स्टंट तरी असू शकेल किंवा काहीतरी एक फंक्शन ऑफ सी कॉन्स्टंट मध्ये पण असू शकेल. सो दॅट implies say right k of c, function of c, okay, plus x. Okay, so that implies what is the value of c now? -1 upon k of x minus y plus x. Okay, give it as an equation number 3. Okay, from 2. Okay, now applying the initial condition given in the problem. ओके, हा तुमचा काय आहे, आलेला सरफेस आहे तुमचा. ओके, z is the function of xy, but we have to find the value of constant k of xy, x minus y. Okay, for that one we have to use the given initial condition. ओके, फर्स्ट सेम मध्ये केलं की नाही, C1 आणि C2 ची व्हॅल्यू काढलाय इनिशियल कंडिशन वापरून, त्याच प्रकारे केलेलं आहे. फक्त पार्शियल डिफरन्शियल इक्वेशन आहे. ओके, टू व्हेरिएबल येतात, z इज द फंक्शन ऑफ एक्स वाय, दोन व्हेरिएबल असतात. तिकडे काय होता, तुमचा कर्व येत होता, इकडे काय आलाय, सरफेस आलाय. ओके, so this is the surface. Okay, now we have to apply the initial condition. What is the initial condition? Z of x naught is equal to f of x, and using that initial condition you have to find the value of k of x minus y. Okay, look at it. Now applying the initial condition. What is the initial condition? Z at x0 is equal to f of x. Okay, function of x. So we have, okay, जिथे जिथे z मध्ये y आहे तिथे 0 पुट करायचं. Okay, so here we get that implies f of x, okay, is equal to, put y is equal to 0 now, so minus 1 into k of x, x minus 0 is x plus x. Okay, so that implies k of x plus x is equal to minus 1 upon f of x. Okay, so that implies k of x is equal to minus 1 upon f of x minus x, which is equal to minus 1 minus x into f of x divided by f of x. Okay, so this is the value of k of x. The k of x हा असेल तर k of x minus y काय असेल? That implies k of x minus y is equal to minus 1. Put instead, replace x by x minus y. Minus 1 minus x minus y into f of x minus y divided by f of x minus y. Okay, now putting the value of k of x minus y in equation number 3rd, we get the required solution which satisfies the given initial condition. Okay, putting these values in equation 3, we have, okay, so z of xy is equal to, what is the equation number 3rd? This one, z of xy, the z means z of xy. Okay, z is the function of xy. Okay, so minus 1 upon minus 1 divided by, okay, what is the k of xy? Okay, k of x minus y, sorry, minus 1 into minus x minus y into f of x minus y divided by f of x minus y plus x, x है ना, so that implies z of xy is equal to minus 1 upon minus 1 into minus x minus y into f of x minus y plus x into f of x minus y. Okay, and हा कुठे जाणार, डिनॉमिनेटरचा वर, so this is minus f of x minus y. Okay, okay, so this is equal to, z is the function of xy. Okay, so this is minus f of x minus y divided by minus 1 to minus x into f of x minus y. Okay, minus minus get plus, so into plus y into f of x minus y, and this plus x into f of x minus y as it is. Okay, so this plus and this minus get cancelled. That equal to z is the function of xy. Okay, so minus f of x minus y divided by minus 1 plus y into f of x minus y. Okay, so this is the required solution, that is z is equal to minus f of x minus y divided by minus 1 plus y into f of x minus y. So this is the required solution, required surface that satisfies the given initial condition. Okay, पहा तू दिलेला आलेला इक्वेशन सॅटिस्फाय करतोय का? पहा zx काढा, find the value of zx, find the value of zy and put in the given partial differential equation. It satisfies the equation. Okay, which one? This one. zx plus zy is equal to z square. यायलाच पाहिजे तो. ओके, आणि इनिशियल कंडिशन सॅटिस्फाय करतोय का? पहा z of x 0 is equal to f of x. येईल का? Look at here. हा काय तुमचा z of x and y. Okay, so z of x 0 काय येईल? Put instead of y is equal to 0 minus f of x. Okay, so minus 1 plus y 0. So here it is y is. So minus minus get plus, so which is equal to f of x. Okay, so it also satisfies the given initial condition. Okay, ज्याप्रमाणे फर्स्ट इयरला करत होतो त्याचप्रमाणे करायचं इथे पण. ओके, तिथं कॉन्स्टंट सी एकच येत होता. Okay, so using initial condition we have to find the value of, okay, k of x. Okay, k of c, function of c असेल इथे. ओके, एकदा वाचल्यानंतर व्यवस्थित कळेल, पहिल्यांदा अवघड वाटेल तुम्हाला. इनिशियल व्हॅल्यू प्रॉब्लेम म्हणजे काय असतं? त्याला इनिशियल कंडिशन दिलेले असतात आणि त्या इनिशियल कंडिशनचा वापर करून आपण काय करतो? कॉन्स्टंटची व्हॅल्यू फाइंड आउट करतो. ओके, इथेही तेच करतोय आपण. इथे आपल्याला तिथे काय मिळणार? इथे इक्वेशन नाही मिळणार, इथे सरफेसचा इक्वेशन मिळेल आपल्याला. z इज द फंक्शन ऑफ x y. ओके, आणि कॉन्स्टंट पण एकटा कॉन्स्टंट नाही येणार, तो हा फंक्शन ऑफ x y येणार, फंक्शन ऑफ कॉन्स्टंट येणार. Okay, so that using that initial value we have to find the k of x. K is the function of constant, k of c. Okay, any doubt?
No, sir.
No, sir.
Okay, एकदा दोनदा वाचा म्हणजे व्यवस्थित समजेल. Okay, one more example. अजून एक example. Example number 2. Solve the equation. Solve the equation x into zy minus y into zx is equal to z with initial condition. The initial condition is same, z of x 0 is equal to f of x. Okay, solve this one. Consider the given partial differential equation. Consider given partial differential equation. X into zy minus y into zx is equal to z. Give it as an equation number 1. Okay, we know that the characteristic curve of equation 1 is given by, we know that characteristic curve of equation 1 is given by ordinary differential equation. Which one? dy by dx is equal to q of xy divided by p of xy. Okay, so that implies, what is the value of q and p? dy by dx is equal to q of xy is minus 1 and p of xy is x. Sorry, हा तुमचा काय आहे? हा पी आहे. पी dx असतो ना, हा
सर P is
capital P.
minus
हा,
P is X,
this
Q
y
is
by
minus Y.
x. ओके, x हा तुमचा q म्हणजे काय असतो? डो z बाय डो y. q स्मॉल q चा हे असतो ना कोएफिशियंट. So this is the q and this is p. Okay, capital P आहे तुमचा. Okay, so here dy, what is the value of p? Q x, and value of p is minus y. Okay, that implies minus y into dy is equal to x into dx. That implies x into dx plus y into dy is equal to 0. On integrating, we get, on integrating, we get, what we get? X square plus y square is equal to c square. Okay, x square upon 2l, y square upon 2l. We assume by here c constant is, integration constant is c square. Okay, so give it as an equation number 2. Okay, now we know that z is the function of xy, that is the given surface, satisfies the ordinary differential equation. Satisfies the ordinary differential equation. Which one ordinary differential equation? This one. Dou z by dou x is equal to dou z by dou x. And what is the dou z by dou x? In the theorem we pile, this one. So zx plus zy upon zy into dy by dx. Okay. So this surface satisfies the ordinary differential equation, this one, which is equal to zx plus zy into dy by dx. Okay, so this dz by dx is equal to, okay, so this is zx plus zy. What is dy by dx? Minus x upon y. Okay, so that is equal to y into zx minus x into zy divided by y. This is dz by dx. Okay, so what is the value of this one now? Y into zx minus x into put the value of x into zy minus y into zx. ओके, काही येईल हा मायनस साइन कॉमन काढल्यानंतर काय येईल? ते काय येईल? प्लस येईल आणि इकडे मायनस येईल. ओके, सो दिस इज द व्हॅल्यू ऑफ झेड नाउ. सो dz by dx is equal to minus z upon y. Okay, so using, so give it as an equation number 3rd. Now using 2 in equation 3rd, equation 3 becomes, what is the equation number 2? Y square is equal to c square minus x square. Nah, so y is equal to what? Square root of c square minus x square. Now putting the values of value of y in this equation, so here we get dz upon dx is equal to minus z upon square root of c square minus x square. Okay, that implies dz upon z plus dx upon, for simplification we get this one, c square minus x square is equal to 0. On integrating, we get 1 upon z integration काय येईल? Log z. Okay. What is the integration of this one? 1 upon square root of and c square minus x square. साइन इनवर्स ऑफ काय
x by a.
एक्स बाय ए. ओके, माहिती आहे ना, मायनस साइन येईल का
Yes, sir.
विथ मायनस साइन. ओके, द
Yes, sir.
कोएफिशिएंट ऑफ सी मायनस आहे ना, विथ मायनस साइन येईल. ओके, so log z minus sin inverse of x by c, okay, is equal to, sorry, log k into c square. Okay, this is the constant. You can take any constant, arbitrary constant. Okay, so that implies
Sir, why to take log k into c square?
हे पुढे सिम्प्लिफिकेशन होण्यासाठी. ओके,
Okay, sir.
No, sir. Sir, hello.
हा बोला.
Sin inverse of x upon c येते ना, फक्त मायनस कसं काय?
मायनस साइन आहे ना ते, मायनस एक्स स्क्वेअर. वेट, मला माहिती आहे.
इंटिग्रेशन ऑफ dx upon in root of 1 minus x square is equal to sin inverse of x असं असतं
साइन
ना.
इनवर्स असं असतं. हो, तेच बघ.
हा, आणि आपण आता इथं dx upon in root of c square minus x square मध्ये c कॉमन काढतो आधी रूट मधलं ना, म्हणजे c. मग c स्क्वेअर ने मल्टिप्लाय डिवाइड करतो, म्हणजे 1 minus x square upon c square येतं. dx upon in root of 1 minus x square upon c square येतं, म्हणजेच dx upon in root of 1 minus x by c चा स्क्वेअर येतो. म्हणून ते 1 upon c into sin inverse of x upon c असं येतं, असं मला वाटतं सर ते इंटिग्रेशन.
1 upon c into येते.
dx upon in sin inverse of x
याचा फॉर्म्युला
फॉर्म्युला 1 upon इंटिग्रेशन ऑफ 1 upon in root of 1 minus x square चा इंटिग्रेशन sin inverse of x येत असतं ना, sin inverse of x येत असतं. मायनस येत नाही सर, मायनस साइन येत नाही. आणि ते c आहे ना, ते आपण सी स्क्वेअर जर कॉमन काढलं तरच, सी स्क्वेअर ने डिवाइड केलं रूट मध्ये तरच ते 1 मायनस एक्स स्क्वेअर आपण सी स्क्वेअर येईल ना, मग त्याच्याशिवाय इंटिग्रेशन कसं येणार?
अपॉन स्क्वेअर रूट ऑफ सी स्क्वेअर मायनस एक्स स्क्वेअर. सॉल्व करा आणि पुन्हा सांगा काही डाऊट असेल तर. ओके, मला जेवढं माहिती आहे त्याचं इंटिग्रेशन हे घ्यायचं. 1 अपॉन स्क्वेअर रूट ऑफ ए स्क्वेअर मायनस एक्स स्क्वेअर इज इक्वल टू साइन इनवर्स ऑफ एक्स अपॉन ए.
सर तिथं 1 upon a पाहिजे.
1 अपॉन ए पाहिजे का इथे? इथे म्हणताय ना?
हा, हो.
असं आहे का? 1 अपॉन ए असेल तर काय येईल मग?
साइन इनवर्स
हा
ऑफ
सर,
x, इंटिग्रेशन ऑफ साइन इनवर्स ऑफ x इज इक्वल्स टू 1 upon रूट ऑफ 1 मायनस एक्स स्क्वेअर आहे ना.
इथे
मग
1
ते
अपॉन
x च्या
सी
ठिकाणी
इक्वल टू 1
x
अपॉन सी
बाय
येते
c
असं मी
ठेवल्यावरती. हा, हो सर.
तेच म्हणत होते.
चेक करूयात आपण पुन्हा एकदा व्यवस्थित. On integrating, we get log z minus 1 upon c into sin inverse of, okay, is equal to log k into c square. Okay. Log z solve करूयात पुढे. थांब, काय येईल बघूया. z. So here we get log z minus log k upon into c square is equal to काय येईल? 1 upon c into sin inverse x upon c. Okay, so that implies log z upon k into c square is equal to 1 upon c into sin inverse of x upon c. Okay.
हॅलो सर.
हाँ
हॅलो सर.
हाँ बोला.
सर इंटिग्रेशन ऑफ 1 अपॉन स्क्वेअर रूट ए स्क्वेअर मायनस एक्स स्क्वेअर डीएक्स इज इक्वल टू साइन इनवर्स एक्स अपॉन ए प्लस सी फॉर्म्युला आहे.
हेच आहे ना, तेच म्हणतोय मी. 1 अपॉन ए
तेच
नाही
बरोबर
आहे.
होतं सर अगोदरचं.
तेच सांगतोय. ते मला फॉर्म्युला नीट लक्षात नाही म्हणून मी पण कन्फ्युज झालो. ओके, मग इथे 1 अपॉन सी नाही येणार. साइन इनवर्स ऑफ एक्स अपॉन सी एवढंच येईल.
येस सर.
ओके, इथे फक्त
पण
1 अपॉन
प्लस
सी
मध्ये
नाही
येईल.
प्लस येईल ना.
हा,
हाँ प्लस, इथे जर प्लस आहे मग इथे प्लस येईल, इथे मायनस येईल. ओके, इथे मायनस ऑफ साइन इनवर्स ऑफ एक्स अपॉन सी. सो दॅट इम्प्लाइज e raised to minus sine inverse of x upon c is equal to z upon k into c square. Okay, so that implies z of xy. Okay, that is z is equal to k of what is the c square? Function of c square है बरं का तो k into c square नहीं, function of c square where k is the integration constant घेतला होता ना आपण log k of c square. Why taking a k of c square? But it is the value of y c square is x square plus y square. Okay, आता कळालं का c square घेतला? Okay, so here we get log of k is the function of k is the integration constant, or it may be the function of constant. Okay, k of c square. So here we get k of c square. Okay, हा तुमचा k of c square आहे. Okay, so here we get that implies k of c square into e raised to minus sine inverse of x upon c. Okay, that implies z is equal to what is the value of c square? K of x square plus y square into e raised to minus sine inverse x upon c. Okay, so give it as an equation number 4. Okay, now what is the initial condition? Using initial condition. Using initial condition, z of x0 is equal to f of x. You have to find the value of k. Okay, so put here f of x instead of y, put here 0. Okay, so that equal to k of x square into sine e raised to minus sine inverse काय येईल तुमचा c स्क्वेअर. c म्हणजे काय येईल तिथे स्क्वेअर रूट ऑफ x स्क्वेअर प्लस y स्क्वेअर ना. इंस्टेड ऑफ c we put x square plus y square. तिथे ठेवा x upon x square plus y square. Now putting y is equal to 0. So here we get only x upon square root of x square. Okay, so x upon x is 1. So here sine inverse 1. C square. F of x. Okay, put y as 0. So here we get k of x square plus म्हणजेच काय येईल 1 येईल ना sin inverse 1. Okay, any doubt आता? What is the sin inverse 1?
Sir, it is n pi.
एकच व्हॅल्यू का कोणती स्टार्टिंग व्हॅल्यू फॉर युनिकनेस
Pi.
pi by 2.
pi by 2.
Pi by
Okay,
2.
sin 91. So minus pi by 2. Okay, so this is the value of f of x is equal to k of x square into e raised to minus pi by 2. So what is the value of k of x square? Is equal to f of x into e raised to minus pi by 2. Okay, if k of x square is this value, then what is the k of x square plus y square? Instead of काय ठेवायचं आहे x square च्या ठिकाणी काय ठेवायला मला x square plus y
सर
square.
ते f of x into e raised to plus pi by 2 येईल ना सर, खाली जाऊन वरती येणार परत.
हा सॉरी
Yes,
इकडे गेला.
sir.
ओके सॉरी प्लस येईल. सो हियर वी गेट जर x स्क्वेअर ची व्हॅल्यू काय येईल x स्क्वेअर प्लस y स्क्वेअर, देन x ची व्हॅल्यू काय येईल f ऑफ स्क्वेअर रूट ऑफ x स्क्वेअर प्लस y square, okay, into e raised to pi by 2. So this is the equation number 5. Now putting the value of k of x square plus y square in which equation? Equation number 4. Again, 4. तुमचा equation 4 आहे. Okay. In this equation, putting the value of k of x square plus y square. Okay. Is it correct? Correct है ना? K of x
सर
square
ते
is
कसं
equal to
आलं
f
k
of x
of
into
x
e
square
raised to
plus
pi by
y?
2 असेल. कुठे हे?
हा सर खालचं.
जर k of x square, k is the function of x square असेल, replace x square by x square plus y square.
सर मग ते f
Okay.
of x plus y यायला पाहिजे ना.
X square जर okay. X replaced by square root of x square plus y square. Now this is the valuation for z of x, y is equal to f of square root of x square plus y square, okay, into e raised to pi by 2 into e raised to minus sine inverse of x upon c. X upon c म्हणजे काय तुमचा x square plus y square. Okay, so this is the required solution which satisfies the initial condition. Okay, कळत नाही आहे का हे कसं आलं? x square रिप्लेस बाय कसं केलंय? इथे काय केलं फर्स्ट एक्झाम्पल मध्ये? ओके, तर k of x काय असेल? -1 upon f of x minus x. Then replacing x by x minus y. इथे पण काय केलं मग? x हा रिप्लेस काय केला? x minus y. ओके, इथे काय होतं तुमचा? x square रिप्लेस्ड बाय x square कशाने रिप्लेस होतोय? x square plus y square. मग x कसा रिप्लेस होईल? याचा स्क्वेअर रूट येईल ना, याचा स्क्वेअर रूट होईल. ओके.
Yes, sir.
Okay. So this is the required solution which satisfies the given partial differential equation and also the initial condition. Okay. In the next lecture, we see that what is the geometry of quasi-linear partial differential equation. Okay. So for today it is sufficient. Okay. Wait a minute.